Alright, boys and girls, we are going to be exploring the triangle congruence theorems, okay? And so they're basically a set of theorems that prove that triangles are basically congruent, okay? So we've already explored congruence in the past with the previous unit, right? So what was the previous unit about? It was about rigid motions. And there's three types that always make a triangle congruent, right? There's the first type where you just shift it and slide it, and that's called translation, right? And then there's the next type over here where you take this and you flip it over to the other side, and that was called reflection. And then the last type was called rotation, where you rotate it. Let's just say this is this is 90 degrees, and then, whoa, this is 90 degrees. Whatever, it's 90 degrees, but it's flipped because it's flipped on the side, but it's rotation, right? Anyway, the idea is that with rigid transformation, the triangle, whatever shape that you were drawing was still the same, right? Same size, same shape, etc. Well, there's a whole bunch of proofs out there. There's actually 4 of them that you're about to see that also proves that a triangle, that 2 triangles are congruent, okay? So let's take a look at this first proof right here. First proof is really obvious, and it's called side, 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 okay? And it makes perfect sense, right? If you know this side and this side are congruent and they're corresponding, and this side is corresponding, and this side is corresponding, that basically implies that all these these 2 triangles are congruent. It makes perfect sense, right? So if this was like 3, 4, and 5, and I told you that this is 3, 4, and 5, guys, I don't know what to tell you. They're corresponding, they're matching, it's side, side, side. That means this is one way to prove that 2 triangles are congruent. It's pretty obvious, okay? So that's easy. Now the next one that you have to learn, which is pretty new, is this idea of what you see here, which is side, angle, side, okay? If you know one side and an angle in between and another side, what you could end up doing is make a prediction that based on the length of this side and the length of this side, that this side has to be equal to this side. And so that's what side, angle, side is basically about. If you're given a side, an angle in between, and another side, that proves that these 2 triangles are congruent. Now, there's 2 more that proves congruence, okay? The next type is called angle, side, angle, okay? Not to be confused, but it's just angle, side, angle. What does angle, side, angle say? If you know an angle, and you have a side and another angle, what ends up happening is that because this is the limit of this angle, it's going to have to meet over there, and the limit of this angle means that the line has to meet over there, and you have this, right? It's the length of these 2 have to be limited, and so therefore, if you know that these angles are corresponding and these angles are corresponding, and you have this, you're given this third side, angle, side, angle is one way to prove that 2 triangles are congruent. And here's the last thing that you have to know. It sounds the same, but it's not really. It's called angle, angle, side, okay? Angle, angle, side, which is really more of the same. It's just this idea that if you're given consecutive angles, like this angle and this side, this forces it, and they are corresponding with another triangle, you're able to conclude that these 2 triangles are congruent. Why? Because if this angle, let's just say, is limited to like 30 degrees, or this is 60, they have to extend whatever this. If this is, let's just say 60, the line has to extend this way, and after 60 it's 30, and so 30 means this line has to extend that way, which makes sense. So therefore this has to extend the same way. Therefore this theorem proves that it's congruent, okay? Now there's 2 other theorems that do not prove congruence, okay? And here they are. The first type is called angle, angle, angle. AAA batteries. Why? Because imagine this was an equilateral triangle. This is 60, 60, 60. But this is also an equilateral triangle. It's 60, 60, 60. And what you notice is that just because you have all the angles doesn't actually make it congruent, because the length of the sides can change as well, okay? So AAA is not good. And here's the last piece. The only time you can really curse in math class, it's the ASS. Or, you know, the correct way is SSA, but it's the ASS. And so just remember, it doesn't work. Why is that? Well, it's basically saying side, side, angle, right? If you look at this, I can draw a similar triangle with a side, but instead of swinging this way to the right, it's still going to be the, let's just say this side is like 5, right? This side can all equally be 5, and it's actually, and if I cover this up, it's actually not congruent because these are two different types of triangles, right? So this is proving why the SSA or ASS triangle does not prove congruent triangles, okay?